Olivia with Prepaze, and today I will be going over the first section of our polynomial series. It's actually going to be building off of our function series that we just completed. So if you haven't seen that yet, go ahead and watch those videos so you can get some good context for what we're going to be talking about with polynomials. So last time we talked about linear expressions, which were always functions. And the reason for that was because we test functions via the vertical line test. Vertical line test says that as long as we pass over our function with a vertical line and it only intersects once, we definitely have a function. And lines will always pass that test because no matter what angle you're tilting at, it's never going to intersect more than once. Now, linear expressions and functions are the diving board into the family of polynomials. Now, before I go into the definition of polynomials, let's look at these two graphs here on the bottom. This first graph here is called a quadratic. It is a type of polynomial, and as you'll see, it does pass our vertical line test. Our second graph here is a trinomial. It has a degree of 3, which I'll talk about more in the next couple slides. And if I pass the vertical line test over it, it's going to be a function. So the great thing about polynomials is that no matter what, it's always going to be a function. A polynomial is always a function. Before I get too ahead of myself here, here's our little notation break. In the past, I've been using y equals to represent our functions, and in the future, I will be interchanging that with f of x. And f of x is just function notation for the output. Y and f of x are equal to the same thing. Cool thing about f of x, though, is that it tracks the input that corresponds to the output that we are describing. So pay attention to that in the future. So polynomial is a word composed of Latin roots, poly being many and nomials being names. For polynomials in particular, we name our polynomial based off of the largest exponent in their algebraic expression. So the name is not a name like Olivia or Sean or Dimitri. No, for a name in this algebraic family, you're going to be referred to as your largest exponent. This largest exponent in your expression is referred to as the degree. Like I talked about in the previous slide, y is equal to 2x plus 3 is linear. And you'll notice the exponent on 2x plus 3, our x value is to the first power. Any value to the first power is equal to itself. That's pretty easy. But as we move on and increase in our family of polynomials, increase in degree, we'll get to larger values like y is equal to x squared plus 2x plus 1. The largest exponent of all of those terms is 2. And so we call it a binomial, special name, quadratic. It's a little bit easier to remember. Then we've got our trinomial with our biggest degree being 3, and that continues for all of the real numbers going forward. 4, 5, 6. Our degrees are of all the real numbers. For those of you who are confused about what does she mean by term? In the next video, we'll be going over the anatomy of a polynomial in standard form, where we break down what a coefficient is, what a variable is, and how they interact. Before I wrap up today's video, I want to make an important note that constant numbers are polynomials too. Let's take the function y is equal to 6. Well, 6 has a degree of 0. If you think of any exponent, any base raised to an exponent of 0, our exponent property is that that value is always equal to 0. So y is equal to x is the same thing as y is equal to 6 multiplied by x to the 0, so that degree is 0, and that's equal to 6 times 1, which is equal to 6. So constants are also in our family of polynomials. Thank you so much for joining me, guys. I'll see you in the next video.